Welcome to the CompTIA Security Plus Guide to Fundamentals Lecture Review. Here we're looking at Chapter 8, Administering a Secured Network. So this is more talking about one of the things. There we go. Common functionality of the actual protocols, principles that network admins can apply to secure the network, and find the different network applications and how they should be used, how they can be used to secure the network. So again, here we're looking at the network itself and the communication protocols used throughout the network. Protocols are rules for communication. Essentially, for proper communication, you have to have a set of rules or standards. When we start talking like verbal communication, us talking, we actually have a lot of de facto standards. Standards we have just because they're not formalized. The pace, the language, the structure, who goes first, do you interrupt someone, things like that. Those are the actual rules for communication. And again, you can actually have set structured rules. Here in the US, we don't have a specific language. English is common, so we use English as a de facto language, but it's reasonable for us to assume that we could do a language in another class, we can do another class in a different language because we do not have a specific standard language. When we're talking about a modern day network, we're talking TCP/IP, or Transmission Control Protocol, Internet Protocol, and that is a suite of protocols that are used for communication on the internet or on a LAN. Again, TCP is a protocol, IP is a protocol, but TCP/IP is a suite or several protocols put together. Alright, so IP is the protocol that functions primarily at the layer 3 of the OSI model. It handles routing, and it also handles IP, or logical addressing. TCP is a layer 4 protocol at the transport layer. It deals with specifically transmission establishing connections, and ensuring reliable data transfer between two devices. TCP is connection oriented, meaning it is guaranteed delivery. TCP/IP also has its own model, and it is a 4-layer architecture broken up into 4 distinct groups: network interface, internet, transport, application. When you compare OSI to the TCP model, they line up pretty common. Layers 7, 6, and 5 line up to application. Layer 4 matches up with transport layer. Layer 3 is the internet layer for TCP, and the data link and physical layer actually are the network interface layers. Got ahead of myself. So you can see there is a very common structure between both of these hierarchy models. We also have other protocols like ICMP or SNMP, DNS, NetBIOS, Telnet. ICMP is going to be one of the big ones. ICMP is Internet Control Message Protocol. You're probably going to most see this in ping, because ping acts as an echo request that actually sends a ICMP request out, and it's used by devices to communicate updates or error information. Basically, it's informational and query message, echo requests, or error messages. Just because ICMP may fail does not necessarily mean that the other end is down. It could just be set to not respond. ICMP has several message fields. We have several different types, codes. It also has a checksum and a message body, though types and codes are the big one. So we actually have several different types of codes. We have a 0 type, we have a 1, a 2, a 3, a 5, a 6, a 7, a 9, and a 12. We have a 4, we have an 8, we have a 10, and 11, but they're not common anymore. So common ICMP code values For type 3, it's going to be like destination port unreachable, source route failed, destination network unknown, and so forth. Attacks that can take advantage of ICMP, because ICMP is what network admins use for verifying that hosts are up. Attackers can use this for network discovery, smurf attacks, you can redirect ICMP, or you can actually have a ping of death. You can manipulate the TTL, or time to live, on a ICMP packet so that the ICMP packets don't die. They just kind of stay relevant in the network. We also have what's called SNMP, or Simple Network Management Protocol. This is used to manage network equipment on the network. It allows administrators to remotely monitor, manage, and configure network devices. Provides basic functions by exchanging management information between network devices, and each SNMP managed device has an agent used for listening and for servicing. Basically, that agent allows the administrator to send update commands to and from it. But from a security standpoint, one of the things we have to be careful of is, while it may help the network administrator in terms of being able to manage the devices and monitor the devices, but if I can access it, so can someone else. So this could be a potential area of concern. There are different versions of SNMP, version 3 being the newest and most secured, but again, there's always holes out there, so it's just a matter of time before someone finds a way to break into it. Alright, moving on. They have passwords. The password is known as a community string. There are security vulnerabilities in the first 2 versions, and again, version 3 uses a password and username along with encryption to address vulnerabilities, but again, nothing is 100% safe. Moving on, we have what's known as DNS, or domain name systems. Very commonly, DNS becomes domain name services, or domain name service, or domain name server. DNS has multiple names, or has one name. It's domain name system, but you'll see that it's interchangeable by a lot of people just in the field. DNS is a protocol that maps IPs to their symbolic or domain names. Google.com is mapped to an IP address. So when you go to Google.com, in reality, you are doing a DNS lookup to see which DNS record has Google.com associated with them, and then from there, going to that IP address. We, people, don't remember IPs. We remember domain names. The equipment, routers, and so forth know IP addresses. So that's why it's important to have a system in place that will translate between domain names and IP addresses. And again, when you look at a web-based domain, google.com, in reality, we are reading it backwards. After the .com, there is a period, even though we don't always see the period. That's called root, and the DNS systems look them up backwards. So period is root, then underneath that we have the .com extension, because within DNS there are multiple DNS extension servers, and Google happens to fall under the .com server. So we go to root, we go to .com, under .com we find Google, and underneath Google, we find the subdomains. For example, www, or mail, or help, or app, or anything .google.com, that first part is going to be a subdomain. So there is a hierarchy structure, and I discuss more of this in my Network Plus material. Here is a 5-step process, and now it actually does the translation. You're looking for local DNS. Step 1, Nashville.com. It goes to the top level DNS server. In this case, it might be a local DNS server. If it doesn't know where that is, it goes to the top level root server. From there, it looks at the .com, .edu, .mil, and so forth. Here we're looking for Nashville.com, so we're looking for the .com DNS. That should return a IP address for the .com DNS server, that'd be step 3. Step 3 will actually then translate it, the Nashville, and then from there should return its IP address, and then from there actually route to the appropriate server. That's how DNS lookup functions. DNS often is focused of attacks because, well, it's simplistic, and it's really easy to, well, break traffic if you can't route off of domain names. What I mean by that is you can do what's called DNS poisoning, or you can actually do like zone transfers. DNS, like the .com, .edu, those are all zones. And so you can have a DNS server host multiple zones. So one DNS server could host .com, and it can also host .edu. Those are different zones, but you can actually attack them. Even better, though, is websites are always updating their IP addresses, so DNS servers must also then update their information. So if you know that, you can take advantage of that to attack the DNS servers to send it updates to google.com. You can then update the pointer, update the record, so that in reality google.com is pointed to a different IP address. There is what's called DNSSEC, or DNS security, that prevents DNS servers from updating the information. However, local DNS servers that are improperly configured can easily be vulnerable and targets of attacks. TCP/IP also has protocols for transferring files. FTP, or File Transfer Protocol, or Trivial File Transfer Protocol, or something called STP. Not Shield Twisted Pair, not Spanning Tree Protocol, but STP in terms of file transfer is Secure Transfer Protocol, because FTP, everything is plain text. Trivial File Transfer Protocol is a light version of FTP, and it's made for very small files. Basically, FTP or Secure FTP, it's built in almost every operating system. You can do it from a command prompt web browser or any file explorer, or even a dedicated FTP/STP client. And all it is used for is transferring files. Now, if they're small files, TFTP is very common. If it's a larger file, then security is not an issue, FTP. If security is an issue, setting up STP is critical. FTP handles 2 ports, 20 and 21. 20 is the data port, 21 is the control port. We have both active and passive FTP, and basically you can set it so that your firewall drops FTP traffic. It just kind of depends on how you want to allow them. If you're dealing with a Cisco or a more common firewall, when you do like an ACL or an ACE, you can do permit FTP, and most firewalls understand that FTP is actually 2 ports, so it opens up both 20 and 21. Here's an example of FileZilla. We have our local and we have our remote on the right. We have our directory information at the bottom, so we can see what files we're copying to or from. FTP is very vulnerable because it doesn't encrypt anything. So we have, again, FTP. Here they're calling it SFTP or FTP over SSL. That's common FTPS. Again, these are 2 different types of techniques. It all depends on who you're talking with or the books that you're looking at. I've seen FTPS, I've seen SFTP, I've seen STP. It just depends on the program. We also have a Linux version called Secure Copy Protocol, SCP. And this is I cannot talk today. This is an enhanced version of the Remote Copy Protocol, RCP, and it does encrypt files. File transfers cannot be interrupted and then resumed. So that's an issue for this, and you mainly find this within Linux. We have a few storage protocols we have to talk about. I'm not quite sure why we're talking about iSCSI or NFS or Fiber Channel or FCOE, but if we're talking storage, we have to be able to have a dedicated storage device that flows over a data network, and so thus we have to worry about transmitting data or large amounts of data. iSCSI is a very common protocol that allows us to do a connection string over a data network, and then it will use SCSI commands. iSCSI or Internet SCSI. Other protocols are Fiber Channel, though this is its own dedicated protocol with its own dedicated hardware. So the layer 2 technology here is not Ethernet, because you'll notice the second option is Fiber Channel over Ethernet, or FCOE. FC by itself is a different layer 2 protocol, so it's not Ethernet. FCOE is Ethernet, and again, basically it is Ethernet that will encapsulate a FC or a fiber channel frame, and that way you can send it over Ethernet. FC to use fast Ethernet networks while preserving the FC protocol structure, basically being able to send FC commands over Ethernet. FC zones are built-in security mechanisms. There are two types of zones, hard and soft zones, though this is way more in depth than what we have to get into when we're talking about storage. Storage and storage security is its own special discipline, and I've already done EMC videos both on basic network storage and security of network storage, so check those videos out. NetBIOS is Network Basic Input Output Systems. It's a transport protocol used by Microsoft systems. It allows applications on separate computers to communicate over a LAN. It is basically a way to view system names and communicate locally instead of using MAC addresses. Telnet is an older version TCP/IP protocol for text-based communication. It's a terminal emulation which you'll use to program like a Cisco router or common switches, because it is a terminal emulation program or application. Telnet does not encrypt anything. Telnet's going away. They are telling you to use secure shell, SSH, instead of Telnet, because SSH can be secured. We have different versions of IP protocol. We have IPv4 and IPv6. IPv6 is the current version, or the newest version. IPv4 is the most widely used version still. IPv4 is limited to roughly about 4 billion public IP addresses and has several security flaws. IPv6 addresses a lot of the weaknesses in IPv4 and has 320 undecillion potential addresses. Though IPv6 is simplified, here are the headers, the layer 3 headers, and you'll notice IPv4, the headers are way more complex than the IPv6. IPv6 headers may be larger, but they're way less complex. One of the nice things is IPv6 does have a lot of built-in security features, so that is a plus. When we're comparing headers for IPv4 and IPv6, for example, the internet header length is not used in IPv6. Type of service is now the traffic class. That's more for QoS. We have a flow label used in IPv6, not used in IPv4. Hop limit, protocol, source and destination address. They're different because IPv4 is 32-bit, or IPv6 is 128-bit. And again, all of that's discussed in Network Plus or in Network Fundamentals, so I'm not going to get too much into that. So the network administration principles basically is administering a secure network is a challenge. It's not simple, it's not easy, and with that involvement comes some challenges. Rule-based management basically relies on the following procedures and rules. You have to set the rules set the procedures and you follow them. That does mean that the rules, the policies, the procedures come first, and then you implement technical controls to actually meet those controls, or to meet those policies. For example, you can actually have every user must change their password every 60 days. Then you implement a technical control to meet that. But the technical control must follow the rule or procedure first. Device security basically involves establishing a secure configuration for the different networking devices, routers, switches, firewalls, and to make sure that they're meeting best practices. Basically, you create a network design, use meaningful names, draw it out first, label it, make sure it's going to meet your needs before implementing any of it, and also then implement some type of change management and update schedule so that any changes that are needed can be thoroughly processed before making changes first. Also, you can make sure it's going to flow correctly. You can make sure it's staying up to date. And again, you structure that so that it's reasonable. You can also then make sure that each device has complex passwords and complex security controls on them to make sure that they are secure as they could be. A few things that we have to talk about are things like FloodGuard. This helps prevent a DOS type attack. FloodGuard also helps prevent sync floods attacks. Basically, the FloodGuard controls the device's tolerance for unanswered service requests. Basically, it does not allow an unlimited amount of service requests that are not completed. So essentially, if you keep trying to do connections and the three-way handshake never completes, the device will only allow so many before it says, no, I'm done, and kills them. Commonly found on IDSs, IPSs, and firewalls. Okay, so now that we've talked about IDSs and IPSs, I know we talked about them in previous chapters, we have to talk about being able to monitor logs. Logs have different forms. Typically we're looking at like security logs or access logs, audit logs, and event logs. While they all may be logs, but they're classified different ways. A security log can reveal types of attacks that are being directed at you or your network. Access logs provide details about requested files or even appropriate access, when they've logged in, when they logged off. Audit logs would be used to record which users performed actions. An event log may document unsuccessful events or even successful events, because maybe you want to track both unsuccessful and successful. And there are reasons for both, but that's not for this lecture. Alright, typically a routine to review the logs should be in place. But let's be realistic. They say you should have a procedure for reviewing logs, but in all honesty, you as an admin will not waste your time reviewing logs. You'll probably have a dashboard, or you'll have like a network analyst doing log review, because there are so many events that will occur in a log or in a log file that you're not going to have time to look at all of them. Though, when you have a dashboard view or a log management software, you could be looking at things like policy violations or fraudulent activities, or even operational problems. For example, you can run queries on logs, what users are logged in at what times. Well, you may be able to detect that this user logged in, but this user was also on vacation, so that could see a policy violation. Logs can be very useful performing audits, supporting organizational investigations, or just supporting external investigations. Also, looking at long-term trends. That's a huge issue. Well, not really an issue, but a use. If I see that every Monday for the last 5 months that at 1:30 p.m. that this event occurs, that can give me as an admin saying, hey, I need to look at this. Logs can provide documentation. Firewalls, routers, all of that can give us detailed logs. Firewall logs can do source and destination. It can also show successful and unsuccessful logins, and so forth. Monitoring and analysis. Here's a nice little log review sheet. If you're looking at DNS, what those logs can do, what DHCP logs can do, what web server logs can do, you guys can look through this. Problems with log management is that multiple devices generate logs. So log files get very large very quick, and devices may not always have the same log formats. Again, normally the solution for this is a centralized log management. Several network design management principles should be followed. Network separation, based off of duties. For example, you may want the regular staff to have one data network, management to have a separate network, accounting to have their own, HR to have their own, printers to have their own, and wireless to have their own. That way we can separate based off of different parts. That way if one network is compromised, they don't compromise all of them. You can physically separate them or separate them via VLANs. Loop protection in form of spanning tree protocol, so we don't have multiple physical routers being looped together. Again, spanning tree protocol. VLAN and VLAN management, both in public VLANs and private VLANs, can be used to segment the network. General principles for VLAN is configure empty switch ports to be an unused VLAN. Change the default VLAN and its name. Configure the ports on the switches to pass tagged VLAN packets. Explicitly forward specific tags. Yes, you can have a trunk port forward all packets, but you may not want that. You may only want to have it set to forward specific VLANs. And again, I've already done videos on this for CCNP switching and for CCNA switching as well. Port security, so that on the layer 2 devices, the layer 2 ports will learn the appropriate MAC addresses, and so that only secure devices can connect to those ports. MAC limiting and MAC filtering, again, same thing. You may want to limit the amount of MAC addresses it can learn, or you may want to limit it to one assigned address. Basically, if you know that port is always going to be linked to a workstation, you may want that port to only know that workstation. Port security comes in different flavors. You can do a static, that's manually entered. You could do a dynamic, which are automatically learned and stored until the switch is restarted, or you can do a sticky. A sticky address are automatically learned and stored with any addresses that were learned prior to the sticky configuration, even if it's removed. 802.1x, this is a port security standard. Basically, it would be port-based authentication, and it will block all traffic on a port-by-port basis until the client is authenticated. Here is a port security authorization. Here's a port security example. Basically, you plug into the network, there will be a authentication back and forth, verifying that you are authorized or not. And if you're not authorized, you don't join the network. If you are authorized, then you do get to join the network. We can have several types of applications and platforms that may also include additional security requirements. For example, VoIP, voice over IP, virtualization or cloud computing resources, IP telephones, VoIP. Because you may have VoIP on a separate network, you're going to have to plan that out. And again, VoIP comes with its own security mechanisms. You can have calls that are selectively forwarded or blocked based off of based off of VoIP phone and its MAC address. It really just depends. VoIP helps simplify management, helps save money, helps reduce infrastructure, but it does come in with some challenges, which is basically you have to have a network admin that understands it. VoIP, lack of encryption, and additional spam. Also, the network will then be opened up to very specific types of attacks. And again, the network admin or the network engineer has to have a VoIP understanding so that they can implement this. Virtualization. Again, that's virtualizing several machines on one physical machine. And again, this has its own set of challenges. And again, most of that comes back to network layout. I've already done several videos on virtualization, so you guys should be covered there. Basically, you'll have one physical machine that has the ability to run several virtual machines, and that comes with challenges. New virtual server machines are easily available, and so can those resources. Helps reduce costs, helps the ability to spin up new servers, and you can cluster them so that if one physical machine goes down, you can actually have them balancing between multiple servers so that certain services are always available. But licensing, costs, complexity, all goes into play. Nice thing is, you can have an environment that you can sandbox, so you can start testing. Security for virtualized environments. Basically, you have to make sure that whatever VM that you bring up is meeting your security profile so that they are kept secure. One of the last areas is cloud computing. Cloud comes in 4 major types: public, private, community, and hybrid. And these are pay-per-use models. Services that are used within the cloud types, for example, software as a service, platform as a service, and infrastructure as a service. Software as a service, basically the provider will access the vendor's software applications running on a cloud infrastructure. Platform will give you your own specialized application or your own specific type of OS. I may want to test my website. I want to see how it operates on different web browsers. I don't want to have to spin up multiple VMs, so I can actually contact a software or platform as a service provider and have them spin up different web browsers on different platforms. That way I can test them. Or I want to test my application on multiple platforms. I don't want to have to spin up my own VMs, so I can just contract the platform as a service. Nice thing with cloud computing is it's on demand, it's universal, typically in invisible resources, and they're elastic, meaning as you need them you can expand as required. Like Microsoft has Azure and Amazon has AWS, you only pay for what you need. Cloud computing security challenges is basically you're putting the data out on the cloud, and there's some regulatory issues that may be come into effect there, but that's a whole other video topic. And that is this chapter in a nutshell. Again, it was more of a understanding the network design and an intro to cloud and some of the basic protocols for networks. If you have any questions, please reach out or leave a comment. I'll get to them as soon as I can. Thank you.